Hello grade 12s, welcome to this final exam preparation video. This is one of many videos to come to help you excel in your final exams, that is Mathematics Paper 1 and Paper 2 exams, right? All the videos will be based on the IEB paper of 2019, so if you have a hard copy that will be good because you'll be able to engage and work along with me as we tackle the different questions. So each video will be based on one question so that we can see how the different topics are assessed or examined in the paper. All right, so I believe you'll be active on your side. You have your stuff there, your stationery, your books are out, and you are definitely preparing for the exams. Okay, how do you approach a question in an exam paper? Every question you want to always start with what is given, because you'll always be given enough information to be able to answer the question or solve the problem. Okay, so if you have the knowledge of what is given, your basis of starting the solution, then that is the right way to approach an exam. That is the right way to approach the questions, right? So we are going to start with question 1, of course, and it is the beginning of section A, and as you know, the IEP papers are split into section A and section B. All right, and my intention is to help you master both sections so that you maximize the marks and your performance and excel in this paper. All right, so let us take a look at the question itself that we're going to answer, and we'll look at the solution thereafter. Here you go. Good. So we're going to start with part A. We are given the following. What is given? -2 is a root. Okay. What is a root? Is an x-intercept of a graph. What type of graph in this case? We're given a quadratic equation. What does the quadratic equation represent? Which function? That is the quadratic function or the parabola. Yes? Good. What is the concavity of the parabola? It is concave up. How do we see that? We see that with the +2 as the coefficient of the leading term. Okay, and by now we know and understand that the parabola can have a maximum of 2 x-intercepts or 2 roots. Okay, what is the corresponding y coordinate at the x-intercepts? It's 0, right? And we can already see that this expression is equated to 0, meaning that if we substitute -2 for x, whatever k is, this expression will be equal to 0. However, this k is supposed to be a particular value according to the question. We must prove it that it is equal to what? -6. So let us do that. How do we approach that? We're going to substitute now for x and solve for k. Okay, what are we going to get here? -2 squared is 4 times 2, it's 8, minus 2, we have a 6 plus k equal to 0, and therefore k is equal to -6. All right. So then the next question becomes a follow-up question where we are asked to determine the other root, that is the other x-intercept. So we have the full equation now, and we can now factorize this to determine the 2 factors giving us the 2 roots or the 2 x-intercepts. Okay, so it's 2x minus 3 and x plus 2 equal to 0. So therefore x is equal to 3 over 2, or x is equal to -2. We already got that root, so the other root is that one, 3 over 2. Okay, so how can we put these 2 solutions into a sketch? How does the sketch look like? Something like this, right? Where it cuts the x-axis at -2 and 3 over 2. Good. So we are moving to question B1 and B2 now. And the two questions there we need to solve for x, right? So here we have an equation that involves a surd, and usually we want to isolate the surd, square both sides, obtain standard format, factorize, and test which solution we're going to approve or accept and which solution we will reject. Okay, so let us see. We have x minus 3 square root of x plus 2 is equal to 2. So we are given an equation that involves a surd. So how do we isolate this? There's a minus 3 here. It will be wise to just transpose it to the right hand side. If it was a plus, you're going to take the x and just transpose it to the right hand side. So in this case, we're going to transpose the surd and bring the 2 to the left hand side. So we have x minus 2 equal to 3 square root of x plus 2, right? And now we are ready to square both sides. Remember, this 3 will be squared as well when you square both sides. So what then do we achieve? X squared minus 4x plus 4 equal to 9 times x plus 2. The cancellation of the square root and the square there happens. And we can now group our like terms. We're going to have a 9x this side, transpose it, we'll have minus 9x plus 4, 9 times 2 is 18, transpose is equal to 0. Okay, let us clean up. We have x squared minus what? 13x. What do we have here? Minus 14, which is equal to 0. So x minus 14 and x plus 1 is equal to 0. Okay, so then we can just say therefore x is equal to 14 or x is equal to negative 1. But actually let us go back and test. If you put 14 here and 14 there, what do we have? We're going to have 14 plus 2, that is 16. Square root of 16 is 4, and 4 times 3 is negative 12, or 4 times negative 3 is negative 12. So 14 minus 12 is 2. Good. So this one works. If we put a negative 1, negative 1 there, we have 2 minus 1, which is 1. Square root of 1 is 1. So we're going to have a negative 3 there, minus 1 giving you a negative 4. So negative 4 is definitely not equal to 2. So we're not going to take this. We can just simply write x is equal to 14 as the final solution. Great stuff. Okay, or you can just also write it as x not equal to negative 1, reject it like that. Good. The last question, B2. What are we given? We're given an inequality. Okay. What is the nature of this inequality? We're given a quadratic expression. What does a quadratic expression represent? A parabola. So do you see the connection there? Okay. Is it in standard format? No. We need to transpose the 6 so that it is less than or equal to 0. So it's x squared minus x minus 6 less than or equal to 0. Okay. So here we are ready to factorize similar to what we've done here, right? So it is x minus 3 and x plus 2 less than or equal to 0. Good. How do we now get to the final solutions? This is not the final solution, these are the factors. Okay, you must find the values of x that satisfies this inequality. Good. What is the concavity of this parabola? It is concave up. Okay. What are we looking for? Where the graph is below the x-axis, because here this expression represents the y values. Okay, while the y values are negative. So what do we have now here? The Cartesian plane. Okay, what are the roots or the critical values here? They will be at negative 2 and 3, and it is concave up. Good. So what are we gonna check? The interval where the y values of the function will be negative. So from negative infinity all the way to the first root here, okay, where is the graph? It is above. So here the y values are positive, right? Between the roots or between the critical values, the graph is below the x-axis, so the y values will be negative. So here now, in our second critical value, to infinity, the graph is above, so we have positive y values there. What are we looking for? We're looking for less than or equal to 0. So the graph must be at the root or below the x-axis. Okay, so this is the region or interval that satisfies this inequality. So therefore, x is between -2 and 3, and we do accept that it can be on the x-axis as the x-intercept or as the critical value. Now, this brings us to the end of question 1. It was 14 marks, and I believe it was straightforward. I did perhaps manage to simplify it for you, and there were notes and important things that were said, or you can rewind and just look at the video again so that you can, get as many knowledge items as possible in this segment of the series. So yeah, the next video will be based on question 2. You can already start doing that by yourself, and check with me when that one is uploaded. All right, so thank you very much. Keep on practicing. Sharp.